Okay, guys, chapter 10. So, number 1 asks, which of the following quadratic functions has a maximum? So, let me remind you, I'm not going to give anything away, but I'll at least tell you what to look for in this problem. So, a quadratic function, remember, is any x squared function. Of course, you can see all of those are x squared functions. They do have parentheses, but at the end of the day, it still is an x squared function. So, if the front of this quadratic, for example, y equals like x squared, it could be, y equals x plus 2 squared or something. It doesn't matter. It's still x and it's still squared. Either way, doesn't matter which of these you have. If the front of this is positive, okay, then your quadratic is a positive graph, which means it's shaped like this. It's a parabola that opens upwards, okay? Whereas if you have a negative up in front, so a negative x squared, or it could be a negative x plus 2 squared, it doesn't really matter, but if you have a negative up front, that quadratic opens downwards, so it'll look something like this. It'll be an upside down parabola. Now, of course, these up here, above my line that I just drew, these vertexes are at the low point of the parabola, so these would have a minimum. Now, the other one, when it's flipped over, like those at the bottom, then the vertex is at the top of the parabola, making those maximum. So when it's asking which of the following functions has a maximum, you're looking for a function that would be shaped like this, that has this characteristic about that whole negative thing, okay? So that's something to keep in mind with quadratics. Positives up front, positive x squareds, or positive numbers in front. It could be a number, it could be 1, or it could be like 3 or whatever. If it's positive, it's going to be opening upwards, making the vertex the minimum, because the vertex would be at the bottom. Whereas if you have any sort of negative number, it doesn't matter if it's -1 or -2 or -1/2. If it's negative, then it opens downwards, making the vertex the top, meaning it's a maximum. Okay, so look and make that determination for yourself. Number 1. Number 2, which of the following quadratic equations can be solved with the graph shown? So this is pretty straightforward. I would honestly just take my calculator. Oh, we already had it there, right? I'd go to my y equals. Again, make sure the window is set to your -10, +10, 1, -10, +10, 1. You don't have to worry about the 6 up at the top, but if it does ever give you an error, then just make sure that number is 6. I don't know why it has to be 6, but just leave it alone. You really should only have to set the x min, x max, x scale, and the same thing for y. I would just take the functions that I see and then look at the graph and see which one looks like the graph that's shown. It tells you it crosses at the point 2, 0 and -3, 0. So yeah, I'd plot those in my y equals and just see which one matches. Now, number 3 is a much trickier one, but it's definitely one that you can manage with a calculator. In a sense, let me at least tell you this much. Here we go. This thing. A vertex form is like this. Y equals a x minus h squared plus k. H and k, these numbers are going to be the vertex. So when I give you an example, like I'll just tell you a, right? A is f of x, or I'm just going to say y equals 8 x minus 3 squared minus 14, right? So I'll go ahead and tell you the vertex of this function is straight up +3, -14. So you do have to be wary that the number inside the parentheses is opposite of what you see. So if you see a -3, it really means that the x value is a +3. But the -14 will be the y value of your vertex. And it's always going to be that way. So answer choice B. Answer choice B is the same thing, but +14, which means that the vertex there would be, again, +3 for the x, because it's still the opposite of this, and then a +14 for the y. So if you can identify those vertexes, or vertices, I guess you could probably technically say, then what I would do is I would graph that original function, the 8x squared I won't show you, but I'll go ahead and plug it in. 8x squared plus 48x, or minus 48x plus 58. I would type that in the calculator. I would graph it. I would see where the vertex is. And then I would look to see which vertex that matched as far as A, B, C, and D goes. I already told you the vertex of A and B, so I think you can probably manage to find the vertex of C and D if you needed to. Now keep in mind, if you can't see on your window the graph, then make your window a little bigger. Maybe go from negative 20 to positive 20 and keep it at 1, and then negative 20 and positive 20 again. It's up to you how you want to change your window. But yeah, you can adjust it a little bit if you need to. Number 4, what is the average rate of change of the quadratic function from x equal to 1, x equal to 3? Okay, so let me work out a problem that's similar to this. Actually, let's leave that open. Open this up. So I'm just going to make up a different quadratic. So let me make up my own quadratic. That's not the same thing as number 4. So I'm going to say, 3x plus 6 squared minus 5 or something. So when it says rate of change, remember rate of change is slope. And to do slope, okay, you're going to use the slope formula, which is y2 minus y1 over x2 minus x1. So to do this, you need 2 points. You need point 1, which we'll call x1, y1. And then you need point 2, which is x2, y2. You just need two ordered pairs. So once we have those two ordered pairs, we can just plug them in. It'll be fine. We'll take the difference of the y's on top. We'll take the difference of the x's on the bottom. Now, we need to get the points. Now, it tells us that we're looking from x equal to 1 to x equal to 3. So it's telling us already that the x value of one point is 1, and the x value of the other point is 3. Okay, so all we have to do is find the y values that go with those. And to find the y values, you can just plug in those x's. So you can take, in my example, it'll be 3, and then I would plug in 1 plus 6 squared minus 5. And I would just type that in the calculator and see what number that is. So I would do, I don't need y equals, I can just go to the normal screen. So what was my equation again? It was 3 and then x plus 6. So it'll be 3, 1 plus 6 squared minus 5. So 3 parentheses 1 plus 6 squared minus 5. Of course, your function's different, but it's the same idea. You just got to plug in your x. And then that gives me a y value of 142. So obviously that's going to be different than yours. But that would be 1 and then 142. Because when I plugged in 1 for x, the y value is 142. So I'll do the same thing for the other x value. The other x value is 3. So I'd plug in 3, and I'd let that do its work, and I'd find its y value. So I would go back to my calculator. I would take this, and I would change that to a 3. And it's 238. Oops, didn't want to do that. So when I plugged in 3, the y value was 238. So now I would just use my slope formula. So if I call this 0.1 and call this 0.2, then plugging it in, I'd have 238 minus 142 on top, and then 3 minus 1 at the bottom. And I would just simplify this. Okay, so you can do your problem exactly the same way. All right. Number 5 asks, what's the y-intercept of the quadratic function? So there's a little trick to this. Remember, y-intercept means a quadratic function crosses the y-axis at that point. So think of it. Anywhere on the y-axis, whether it's here or down here or here or here, wherever, obviously the y value is always going to be different. But if it's on the y-axis, it's always where x equals 0. When x is 0, right? Because this point here would be like 0, -2 or something. This point here would be the point 0, -4 or whatever. I'm just making that up. But like, this one here would be 0, negative, or 0, +3 or something. Either way, the y value will be different. But every point on the y-axis, x is 0. So that's a clue. Basically, if it's asking you to find the y-intercept, then you know that it's the y value whenever x is 0. So simply, all you have to do is plug in 0 for the x value. As you can see in all the ordered pair answers, all the ordered pair answers have 0 as the x value. Plug in that 0 to your function and let the calculator tell you what the y value is. Okay. So the graph, number 6, the graph of the quadratic function is shown. Based on this information, how many solutions does the quadratic equation have? So remember, solutions are just how many times it crosses the x-axis. So if you have a graph that crosses the x-axis twice, then it has 2 solutions. Okay, or at least it has 2 real solutions. If it crosses the graph 4 times, the x-axis that is 4 times, doesn't matter where it crossed the y, it just matters the x values. If it crossed the x-axis 4 times, then it has 4 solutions. If it, doesn't cross the axis at all, right, then it doesn't have any solutions. So basically, you're just looking to see where it crosses the x-axis. You're just counting how many times it crosses the x-axis. That's it. That was number 6, right? Okay, number 7. According to the graph, Holly's family is parked for a total of 3 hours and 15 minutes. How much will they pay for parking? So, I think you guys can kind of manage that. It's just basically looking on the graph at a certain point, looking at where 3 hours and 15 minutes would roughly be, and then seeing what y value that would be. So to give you somewhat of an example to follow, let's say that I have 1, 2, 3, 4 hours, and let's just say that this is like 5, 10, 15, 20, right? And let's say that mine was, I guess like this. It looks kind of weird, but it's actually pretty simple to read. So if I was looking at the price at 2.5 hours, well, 2.5 hours would be right here, right? Right between 2 and 3. And if I go up, I'll see that I'd be on this line, which is at $10, if this is money over here, right? So that means if I, park for 2.5 hours, I have to pay $10. Whereas if I park for 3 hours and 45 minutes, 3 hours, 45 minutes would be like right there, right? I'd go up and I would see, hey, I have to pay this much money, which would be, if I make a good graph, it'd be about $15. Now you do gotta be a little careful because if you're at exactly 3, right? There's 2 circles here, right? But you of course go with the circle that's filled in, not the one that's open. The one that's filled in means it's being used. The one that's open means it's not being used. So for 3 hours, the point is here, which would be $10. If it's any more than 3 hours, if it's 3 hours and like 2 minutes, right? Then you're going to be on the line up there. You're going to not be on this point. You're going to be on the line. That would be $15. So up to 3 hours, you pay $10. But if you go anywhere past 3 hours, you're on this line up here, which would be 15. So that's just how to read that graph. So you can read your graph on number 7, and I think you'll manage to figure it out. So number 8 asks, what's the maximum amount Holly's family could pay for parking? So basically, what's the highest the price goes? You can see that on the graph, where the top of the graph is. Yeah, I think you can manage that. That's just looking at the graph and reading it. All right, that's it for chapter 10. I'll see you guys in chapter 11.